Welcome to the part 2 of naming of compound. Part 2, second series of naming of compound. And in this one, we are going to look at what binary compound, still same binary compound, but under this we look at how to what name group 3 binary compound and what transition metals binary compound. And I told you that the oxidation number of hydrogen is +1. But in metallic hydride and what ionic hydride, it is -1. I've explained the ionic what binary compound, but I've never explained the ionic hydride. But I've explained ionic binary compound. When group 1 metals and group 2 metals react with what? Non-metals. That is ionic binary compound. In this case, I will explain what group 3 binary compound and transition metals binary compound. And I will quickly talk on what metallic hydride compound. Take note of that. Let us move. Still on the first rule, that when two elements combine together to form a compound, the last element carries what? IDE. Now, I want to take what? Group 3 metals now. Group 3 metals. That means when you have aluminium chloride, if you were asked to write the chemical formula of aluminium chloride, the rule is still when you have two elements combined together to form a compound, the last element carry IDE. From here, you know that there are two elements here, which are aluminium and what? Chlorine. And you know that aluminium is what? Group 3. Aluminium is group 3. And what is the oxidation number? +3. Chlorine is what? Group 7. The oxidation number is -1. Then valency, combining power. This comes here, this goes there. You have Al1, Cl3. Since it is 1, there's no need to write 1. That means chemical formula of aluminium chloride. If you are asked to write chemical formula of aluminium oxide, that means aluminium and what? Oxygen. And you know that aluminium is what? +3. Oxygen in group 6. Group 6, they have oxidation number of -2. That means -2. Valency. Valency is combining power. Come here, go there. You have Al2O3, aluminium oxide. If you are asked to write aluminium nitride, for example, nitride, that means aluminium and what? Nitrogen. Aluminium is what? +3. You can see. And nitrogen is what? -3. Group 5. What happened? +3 -3. The same figure, but different sign. The same figure they cancel. That is aluminium nitride. If you are asked to write beryllium, let me rub up this. Let me rub it off. If you have beryllium oxide, boron rather. I'm sorry, boron, group 3. Boron oxide. What will you do? Boron is what? B, oxygen, 0. O, rather, oxygen, O, not 0. O, we are in chemistry, not 0. Oxygen, O, boron, B. That means oxygen is what? +3. Oxygen is what? Boron is +3. Oxygen is what? -2. What happened? This come here, this goes here. You have B2O3. This is what? Boron oxide. Boron oxide. If you have boron fluoride, that means boron and what? Fluorine. Boron is what? +3. Fluorine is -1. What happened? Come here. B -1 come here as 1. Then L3. Boron fluoride. etc. Let us move to transition metals. Transition binary compound. Transition metals binary compound. That means when you have transition metal combining with what? Non-metals to form binary compound. When you have transition metal and what? Non-metals to form what? Binary compound. And let me give you the first set of what? Transition metals in their first period. The first period of transition metals, which can be found in period 4. We have scandium, titanium, vanadium, chromium, manganese, we have iron, we have cobalt, we have nickel, we have copper, we have zinc. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one, oxidation number of +3. This one, oxidation number of +2 +3. Yes, +2 +3. There, +2 +3. I'm coming, please, I'm dehydrated. +2 +3 +4. This one, +2 +3 +4 +5. This one, +2 +3 +4 +5 +6. +2 +3 +4 +5 +6 +7. +2 +3 +4 +5 +6. +2 +3 +4 +5 +2 +3 +4 +1 +2 +2. Take note. What is transition metal? One of the characteristics of transition metals is that they have variable oxidation state. They have variable oxidation number. Apart from what? Zinc and what? Scandium. Zinc, scandium. But the other, they have variable oxidation state. Can you see variable oxidation state? I've given you their oxidation state. For titanium, it has what? 3 variable what? It has 3 set of what? Oxidation number. Then because of this, how can you name transition metals? Transition metals binary compound. Because you have to identify the oxidation number of that word, transition what? Metal. For example, if you have this, look at this. If you are asked to, we have iron 3 chloride. Iron 3 chloride. If you look at this, how many elements are here? 2 in this compound. Iron and what? Chlorine. These 3 in Roman numeral, these 3 in Roman figure indicate the oxidation number of iron. Take note of that. These 3 that is in Roman word figure indicate oxidation number of what? Iron. Then how can we write this word? This formula. That means I have iron and what? And chlorine. Fe is iron. I have iron and what? Chlorine. These 3 indicate that the oxidation number of iron is what? +3. I have +3. Then chlorine, you know that is -1. I have -1. Then what happened? The valency combined power. This come here, that come here. You have iron 1. This one come here 1. Then Cl3. This is what? Iron 3 chloride. Iron 3 chloride. Iron 3 chloride. Take note of that. If you have, look at this. You have cobalt 2 fluoride. Cobalt 2 fluoride. What happened? These 2 indicate that the oxidation number of cobalt is what? +2. The number that is in Roman figure indicate the oxidation number of that word transition metal. Take note. The what? The Roman figure, the Roman figure you have in the bracket indicates. The Roman figure you have in the bracket indicate the oxidation number of the word transition metal. What is the Roman figure in the bracket? The Roman numeral in the bracket 2. These 2 indicate oxidation number of that word cobalt. Indicate oxidation number of what? Cobalt. Therefore, cobalt 2 fluoride. That means we have cobalt. C small letter O. Take note. It's not C capital O. Capital C capital O is what? Another compound. This one is what? Carbon 2 oxide, which I'm coming to. Take note. Capital C, small letter O, cobalt. Then cobalt, the oxidation number is what? +2. Fluorine, oxidation number of fluorine is what? -1. Therefore, this one comes here, this one go there. Then you have cobalt 2 what? Fluoride. Take note. Cobalt 2 fluoride. If you have this, look at this. Look at this. Or if I ask you, what is the name of this compound? Look at this. If I say, oh, look at this, look at this. CuCl2. CuCl2. Take note, sometimes the number that is here does not necessarily show or do not always show. Let me put it like that. The number you have here does not what? Always show. It doesn't show, it does not always show that the oxidation number of copper is 2. The number here does not always show that the oxidation number of what? Copper is what? 2. In this case, to name this compound, I'll first of all find the oxidation number of what? Copper. I'll first of all find the oxidation number of copper. Take note, find the oxidation number of copper. How will I find the oxidation number of copper? Copper, oxidation number unknown, X, plus oxidation number of chlorine, I know that is what? -1. Then how many chlorine do I have? 2 times 2 equal to 0. Why is it 0? Because this is a neutral compound. Neutral compound is a compound that has what? Net charge of 0. That has what? Net charge. Total charge of what? 0. The net charge of this compound is 0. It's a neutral word compound. It has no charge. It carries no charge. That's what equal to what? 0. Copper, the oxidation number is what? Unknown. Chlorine, the oxidation number is -1. How many chlorine do I have? 2. M times 2 equal to what? 0. Then I have X. Plus times -1, -1. -1 times 2 will give you what? -2 equal to 0. Plus times -1, -1. -1 times 2 will give you -2. Then S equal to this one, you have 0 plus 2. S equal to what? +2. That means oxidation number of copper is what? +2. Therefore, the name of this copper is what? Copper 2 chloride. Copper 2 chloride. Because it's a transition method, you have to indicate the oxidation number. That is the name of this compound was copper. Then because it's a transition method that has what? Variable oxidation number. Indicate that oxidation number in numeral figure, Roman figure. Copper 2, then chlorine, chloride. There are 2 elements. The last element carry ID. Copper 2 what? Chloride. Take note. Look at this. Look at this. You can pause or have you written this? Have you written this? Let me rub this one off. Let me rub it off. Let me rub it off. Look at this. Look at this. Look at this. When you have something like this, when you have MD3, okay, P5, let me, B3, P5. This one is vanadium. This is vanadium. Vanadium is what? Transition method. It has variable oxidation number. Take note of that. This does not always, it doesn't show, always, it does not, sometimes it could be the oxidation number for vanadium, but does not always show that it's the oxidation number of vanadium. How do we do it? Find the oxidation number of what? Vanadium. That means oxidation number of vanadium unknown. Let me call it X. And how many vanadium do I have? 3. That means 3 times X. Because oxidation number of vanadium is X, unknown, is one I'm looking for. Then how many of vanadium do I have? 3. That is 3 times what? X. Then plus oxidation number of phosphorus. This is phosphorus. The oxidation number is -3 plus oxidation number of phosphorus -3. How many phosphorus? 5 times 5 Everything equal to what? 0 is a neutral compound that has no charge here. It's a neutral compound. Therefore, I have 3x plus times minus 3 minus 3. Minus 3 times 5 will give you what? Minus 15 equal to 0. Therefore, 3x equal to this one moved out. 0 plus 15. 3x equal to what? Plus 15. Therefore, divide both sides by 3. Therefore, you have s equal to what? Plus 5. That means oscillation number of vanadium is what? Plus 5. Oscillation number of vanadium is what? Plus 5. Then what will be the name of this number? Vanadium. Vanadium indicates the oscillation number of vanadium because it's a transition metal that has variable oscillation number. Indicate the oscillation number of vanadium in this compound using Roman numeral, Roman word figure. That is vanadium 5. Then fluorine, phosphorus rather. Phosphorus is the last element which we carry what? IDE. Vanadium 5 or fluoride. Phosphoride. Phosphoride. I'm sorry, phosphoride. It's a phosphorus. Vanadium 5 phosphoride. Please take note. Vanadium 5 or phosphoride. Take note of that. 5 phosphoride. Vanadium 5 phosphoride. Look at this one. Look at this one. Look at this. Look at this. When you have Fe2O3. Fe2O3. What is the name of this compound? How do we do it? Calculate the oxidation number of ion. But this does not always show that the oxidation number of ion is what? Plus 3. Calculate. Oxidation number of ion, I don't know, x. How many ion do I have? 2. That is 2x plus minus 2 times what? Oxidation number of oxygen is minus 2. Minus 2 times what? 3. Everything equal to 0. You have 2s, everything minus 6 equal to 0. You have 2s equal to 0 plus 6. You have 2s equal to plus 6. Divide both sides by 2. You have s equal to 1 plus 3. Oxidation number of ion is plus 3. Then what will be the name? Indicate the oxidation number of ion using Roman figure. Therefore, ion is what? Ion 3. Oxygen is the last element. We will carry ID. 3 what? Or side. Take note of that. That is how to write chemical formula of what and to name what transition metal. Please don't forget, subscribe to our YouTube channel, share, comment, share it with your friend, like it, and what ask more questions. You will see a WhatsApp link below. You can click on it. You will join our WhatsApp group. Bro, my name is Chama from Notisan. I remain myself. Thank you.